Record. All right, I'm going to record from now. So we missed some 1 minute or 2 minutes. So we want to solve this question, this equation in terms of y for v. All right, so first derivative, v is the speed or velocity of the rocket. Y is the position of the rocket in any time. And v is the its derivative because it's velocity. Second derivative of this one is this guy. So I should write 2 here. So this is equal to this guy here. So therefore, this will be dv over dt. Now, so I've got this equation here. All right. So if I, instead of the left-hand side, will be subbed by this dv over dt. Okay. So this one equal to minus gr squared divided by y squared. Now, so this OD has got 3 variables. Okay. So as in the yesterday's question in me-test session, we need to decrease it to the 2 variables. So dv over dt is equal to dv over dy times dy over dt. Okay, so this guy is v. So this will be v times dv over dy. So the left hand side will be this guy. All right, so this one will be solvable. It is separable. V from dv equal to plus gr squared, this guy here, dy, so separable ODE. So what I did differently rather than compared to the tutorial solution is integral from v0 to v. Integral from y0 to y. Okay, so y0 because the rocket starts from the from ground. Okay. So I've got this one, I've got this one, so v squared. So this y, the integration of this one, subbing the boundaries, so I will get this one. So gr squared is coming here, and this guy is 1 over y. And I will sub the boundaries of the bounds of the integral. So these guys, so v squared is this guy. And v can be this, because v goes to the up. So it's positive animal. So I will choose positive here. Third of v0 squared plus this guy here. So in square of this guy. So what happened to the c? If I were not using these v and v0 here, I would have c constant. That constant can be this one. All right. But I didn't do that because you will see that see these in the tutorial solution. Tutorial solution of this week and last week has been released in Canvas last week. So it's meaningless if I do some repetition work. Okay, enough until here. Part B. What's this v0? Initial velocity. So velocity, so the velocity of the I don't know, rocket, space, whatever, I don't know, James Webb space, whatever, goes up. So it should have a initial velocity. So let's see this velocity. We will not obtain some velocity, but read the tutorial solution because the velocity that we obtain here, it's very unreal. It's impossible to obtain that velocity. Okay, so v0, because this velocity, the velocity that we will obtain, it will be more than or faster than the, like, what's this? Shooting? Yeah, shooting a bullet. So this means it's impossible. Okay. The rocket goes up, at least we see, and like initially it goes slowly. It means it's not depending only on the initial velocity. It's depending, according that even the real solution and even as I investigated, it's depending on the local velocity, local. Okay. Now v0. So it's escaping from the dominating gravity of the ground. It means you have enough distance. Okay. So that when the rocket is far from enoughly from the earth, it means you go up, you have good distance from the earth. It means big distance, and it means there is no friction, and you stop there. So the velocity, the later velocity or endpoint velocity is 0. Okay. So at that time, your not initial velocity, but the at that time the velocity is 0. Okay. So this means y position, it goes to the big number, not plus infinity. It's not true, but it's a big number. Okay. And the velocity at that time is 0. It's tending to be slower, not really 0. So this guy here, this will be 0, and this y will be big number. As a result, this fraction will be a tiny animal. So this will be 0 equal v0 squared minus 2gr. So v0 squared minus 2gr. So therefore, inside third is 0. So from here, you can get this one. And we choose positive because v0 is the direction of the v0 is to the up. It's positive. Now, g is the, what's g? Pardon?
Oh, gravity.
Gravity.
Yeah.
G, 10 or 9.8, yes?
Oh, yeah.
We've got two G's. So capitalized G is the global gravity, that one. I don't remember. That's not more famous. But little g is the acceleration of the gravity. So which is a fixed 9.8. Now, so R is the, as I said, radius of the Earth. So radius of the Earth is this guy. Okay. And G is this guy. So you stop here and you can find V0. For the moon is this guy, 1.6. So if you jump in the moon, since this is lower number, you will go more. You will go higher. And the radius is less. So the velocity, initial velocity needed there will be less. But you will read the solution because it has enough. So it's just substituting. It has some extra interesting information. Now, let's do another. This is this is famous example. Okay, so it's better to know. You get the degree from maths department, so you should be able to know this question, rabbit question. It's famous. Okay, so a rabbit is here. Okay, why do we do this? Although the tutorial solution is there, because it's not well explained. Okay, so a rabbit is here and a dog or whatever is here. Okay, so a rabbit starts through this path. Okay, for simplicity, we assume that it's taking only at this path. So the dog is seeing this rabbit firstly here. Then the rabbit is here, the dog is pursuing the rabbit. Okay. So what happens? Let's ask it. So the XR is the location of the rabbit, which is 0. As a result, its derivative in terms of time is 0. The location of the y-axis of rabbit is YR. Okay, Y rabbit is this guy. But we know that Now, it was here C0. The dog coming with the fixed velocity. Okay, we are lucky. So its the velocity is B. The velocity of the rabbit is A. After T times, its velocity will be A times T. Okay, so that's Y prime of the velocity of rabbit is A. So if I solve this one, what is this? Okay. So velocity of rabbit is A. So if I solve this one, it will be AT plus C, but I started from 0, so C will be 0. So Y, the location of the rabbit after T, it is AT, but we know that already. We could see that. Now, we have been asked to model the path of the dog. It means, what does that mean? It means in any arbitrary here, we need to know that what these XD, YD, what the hell they are. XD, YD. Okay. So we are after for X location of the dog. So velocity of dog is these guys, derivative of these guys in terms of time. This guy. Now, let's assume that the dog is here. The dog is here, and this rabbit is here. Okay, so see that since it's pursuing, anytime it's like going, the path, the velocity is always the tangent line. And this dog is seeing the rabbit. If the rabbit is here, the dog is here, it's pursuing. So the tangent line is the same line as this. But the tangent line in the path is always showing the vector of velocity. Okay, you have seen in the physics that velocity vector is a tangent vector or tangent line to the location, to the curve, to the yeah, you got what I mean. Now here you see that this point here, YD XD. I want to know this XD YD, but I have a trick. This is a line. So this is a line, this is a line. So this line has this Earth and Australia equation. YD minus Y0 M slope gradient XT minus X0. Okay, so what we are doing, Y0 is just 0. No. So we want to obtain one by one. Sorry. We need to know Y0, M, X0. But what's the X0, Y0? It comes from the pursuing. So X0, XD, YD, and I can use this point. X0 of this point is 0. Y0 of this guy is 80. Okay. So Y0, I choose 80, X0 is 0. Okay, because I use this point as another second point. Okay. Now, so now what is M? Okay, I got Y0, I have the X0, I need to determine M. What's M? M is this guy here as the since the velocity is a tangent vector, which I explained, so the initial tangent vector at the XD and YD here. So this vector, you see that this vector is equal to this vector. So I can move this vector to here. Okay, then I can know that it's theta, or as a result, M, the gradient. So if a vector, initial point of the vector, starts from origin, so the m of that point or tangent of that vector, vector will be equal this guy. Are you happy with this? All right. So therefore, this guy here will be converted to yd minus y0 times m xd minus x0. Okay, xd. So that's why in the tutorial solution, in one shot, suddenly you see this guy. Suddenly. So we need to have good explanation. Actually, this guy. So now from here, I can just rearrange the equation. From here, I can differentiate this because t, y, x, three variables, unfortunately. What we do, the trick is this. Instead, this is the first order. So we take into different derivative in terms of x on both sides. So this will be x, y double dash plus y prime equal to this guy. The derivative of this guy is y prime minus a. So t in terms of x, dt over dx. So we cancel this. So it will be x, y, dt over dx. So dt over dx is another annoying expression. So we don't have x. It's a curve, okay? It's not a line. So I can write dt dx in like this, dt over ds times ds over dx. So first expression, the reciprocal of this guy means ds over dt is the velocity of the dog in the path at the time t, which is b, because it's a fixed velocity of the dog. So I will, for this one, for the first fraction, I will sub 1 over b. ds over dx, I don't need to explain because you've got the 2 weeks ago, you saw the lengths of a curve in Math2800. But let's see the explanation. ds over dx, the rate of the change of the path in terms of x. Epsilon piece of the curve or s is delta s. Delta s is approximately equal to Euclidean Pythagoras formula, delta x squared plus delta y squared. So delta y is y minus y0, m times x minus x0. So this m times delta x, so m is just y prime. Delta x, so delta s will be equal square root of delta x squared plus y prime delta x squared. So from here, I can write this guy. Delta x squared comes outside by negative sign because the dog is going to the left. So it means delta x is decreasing. So delta x will be minus delta x. Now from here, you can see that s is equal minus third of 1 plus y prime squared x. If I take a derivative of this guy in terms of x, this will be the answer. So that's why ds over dx is this guy. However, we know that the length of the curve for implicit functions, you know what to do. It's integral of the square root of x prime squared plus y prime squared. But explicit you've seen in the Math2800, it is 1 plus y prime squared. Now that's why ds is this guy. So 5 will be xy, this guy, this guy. So for the rest of the so this one is obtained, and the rest of the thing that I won't do anything. So it's just obviously I should take y prime equal to p and proceed. The rest of the things is in tutorial solution. All right. The hardest part was this guy to obtain. So one of the problem of the real mathematics of the OD is to understand the problem, modeling it, and put it in the OD. The rest of the things is okay. In any way, it will be solved. Either by soft computing or just other methods. Okay, let's go other week. Question 2, we've done it. Week 7, question 2, part A. Okay, so you need to help me because I have not written. So the first ever thing that I can do to obtain A minus lambda I, which will be 1 minus lambda, 2, 4, 3 minus lambda. This will this determinant is not only determinant to obtain the lambda, but also this gives me the characteristic equation that you have seen this Monday. Yeah, last Monday you saw that this is the characteristic equation of a matrix. Okay, equals 0. So from here, 1 minus lambda, 2 minus lambda, minus 8 equals 0. So from here, lambda minus 1, lambda minus 2. Okay. Yeah, fix me. Yes, it should be 3. All right, so from here, it will be lambda squared minus 4 lambda. That will be positive 3 with minus 8 will be minus 5. So what is this? Is should be minus 5 lambda plus 1 equals 0. So from here, is that right?
Yeah.
Yeah, for the first time, it's right.
I was just hoping they were complex, so I could see how to answer it properly.
No, I solved the easy one here, but hard one for you.
That's unfair, actually.
But we've done question part 2, B, C. They were repeated version, and you have seen my handwritings probably last week, yeah? So we were doing the complex version, repeated version, and for the complex version, I did 2 methods. Now, for this one, okay, it is easy for me to do eigenvectors, but we don't like it. Let's use Cayley stuff. Alpha 0 I plus alpha 1 t times A. So this is equal, not, but e to the lambda e alpha 0 t plus alpha 1 t lambda. For since it's not repeated, so I don't like to take a derivative. So this will be e to the 5 t alpha 0 t plus alpha 1 5. The other one is e to the minus t alpha 0 t minus alpha 1 t. So can I move this guy here? Page, this guy here. All right, so this one here, I multiplied by 5. So, so this will be the 5t alpha 0 t plus 5 alpha 1 t. This will be 5 into the minus t alpha 0. So from here, alpha 0 t will be e to the 5t plus 5e to the minus t divided by 6. Alpha 1t is equal to, I use this question number, all right, from alpha 1t is equal alpha 0t minus e to the minus t. So from here, e to the, what's that? E to the 5t. Are you with me? Alpha 0 plus 5e to the minus t divided by 6 plus 6 times e to the minus t divided by 6. This will be 6e to the 5t, 5e to the minus t. This should be subtraction. This will be e to the minus t, which you didn't fix me. All right, so from here, x will be e to the a t times c1, c2. This will be alpha 0. Can I write alpha 0? E to the 5t plus 5 e to the minus t divided by 6 times I, actually parentheses, plus e to the 5t alpha 1 divided by 6 times a times c1, c2. So you get this one. I missed lots of steps. You get this one, this guy here. But if you do eigenvectors, you see big X will be C1 e to the 5t, something here, V1, 1, V, what? 2, 1 plus C2 e to the minus t, V2, 1, V2, 2. Now, you see this guy here is e to the minus t. This guy has this one, this one. In fact, these ones, the first, this guy is the linear combination of this e to the 5t, e to the minus t. But for the distinct eigenvalues, don't use this alpha 0, alpha 1 method. Don't use Cayley-Hamilton method. Use the normal thing. Okay? But we just did this one because we want to practice. Okay, let's go other question. This one. Determinant of this 2, 1. What do I do? Okay. 2 minus lambda, 1 minus 3, 6 minus lambda equal 0. 2 minus lambda, therefore, right arrow. 6 minus lambda, this will be minus 3 plus 1 equal 0. From here, lambda minus 2, lambda minus 6 plus 3 equals 0. From here, lambda squared minus 8 lambda plus 12 plus 3 plus 15. Okay, what is this?
frame five.
Yes. So lambda equal 3 minus 3 minus 5, it will be this one. Okay, e to the a t can be written as so okay, one thing. Can I so I wanna use this one, a times eigenvector equal to eigenvalue dt or pd. So this will be a equal to p d. So multiply this one from the right, p inverse. What's p? The columns of the p? Excellent. Yeah. So what's this? Eigenvector. Now, AV equal to 5V. So this will be, oh God, this guy, what's A? What's A? 2, 1 minus 3, 6. 2, 1, 2, 1 minus 3, 6 is this. Yeah. So this guy 3. So x, so 5 comes to the left. So this will be 5. Am I right?
Yeah.
So this, can I simplify this? This 1 minus 3, 1. See this. Yeah. So it's not really okay. So that will be that. So minus 3x minus 3v 1 1 plus v 2 1. You know what I mean? Definitely. So v, let v 1 1 be t, then v 2 1 is 3 times t. So this add pages. So it's not part of mathematics, sorry. All right, so v v1 will be any multiplication of that one, 1 and 3. So v2, so I will spend 5 minutes for this question, and we have the important question here. v2 can I find it? What was this? 2 1 2 1 minus 3 6 should be 0 0. What was the other eigenvalue? 3 minus 3 minus 3. So this will be minus 1 1 3. What's this? This will be also the second row will be 0. So minus v2 1 plus v2 2 equals 0. From here, v2 1 equal v2 2 equal t. So second eigenvector will be 1 1. Now, so P is, therefore P is I see this one. 3, 3. What was the other one? 1, 3, 1, 3. So D will be correspondingly in the same order. 3, 0, 0. What's this? Yeah, 5. Okay, 5. Yes. All right. Shoot. P inverse. Okay. Oh my God.
It's 3 minus 1, minus 1, 1. No. Put the diagonal.
P inverse, the inverse of this guy.
Yeah.
All right.
Split
Okay.
A and D.
Tell me. Okay. What's this?
I think it's just 3 minus 1, minus 1, 1.
1. Can I try one number? So if I try this one, this guy with this one will be 3. It didn't work.
You're gonna do, yeah, 1 over the determinant.
So what's the determinant of the 1, 3? 3 minus this one will be, so it will be 3 minus 1, 2. So okay, whatever. So P inverse is this one. So now, so the answer is x equal to the a t times c1 and c2. But here, instead of e to the at, we put p d p inverse t times c1 and c2. So this will be something. So this will be okay. So we have to obtain this guy. So P D P inverse T. Okay. Okay, I will complete this one and I will write later. I will write in my handwriting and I will. So I'm just confused. Okay. Okay, it will be very long. So I will complete this part and sorry guys. So let's do this one. So this one, when the coefficient matrix A is 1, 2, 0, 0, 1, 2, it's diagonal matrix. That's why we want to convert that A to the diagonal one. B, the flux of easy. When I try to obtain e to the AT, this will be just e to the 1t, 0, 0. This 2 will be e to the 2t. That's why we are happy with this. So, okay, for this one, e to the this guy is e to the 1t, e to the 0, 0, e to the 2t. C is just C1, C2. And we can obtain this one. So instead of B, C, let me prove this one. Then instead of this one, what we can do is just the last year's assignment matrix. So this is A was like this, and F was like this. And it was like 8 marks. So now part A. If I take derivative in terms of t, see this guy, this will be a times e to the a t c. This guy, the second expression will be at the product rule. Derivative of this one times this. A times at integral 0 t minus s f ds plus what's the integral, what's the derivative of this one? Huh? What should I write this one? Not this. T. So this integral, the derivative of this integral will be that first principle of the integration and the first principle of the calculus. This will be e to the a minus at times f. So outside I will write this guy, then times derivative of this guy will be e to the a t times derivative of the integral will be e to the minus a t f. Now here, do you see this guy? They cancel each other. I. So I times f will be f. And also, sorry, and also there is a. If I take integral from differentiation, integration, there is a minus a here. So I will put, I have minus a. So this will be a, all right, times e to the a t c. These will pink colors will cancel each other. This will be e to the a t. Okay. E to the a t integral 0 t e to the minus a s f ds bracket closed minus whatever I have here minus a times f. Now inside this one, this guy, do you see this guy? This guy is equal to so yes, it is x. Excellent. Oops, yeah. Thanks. So this will be a times x minus a f. So x, that's right. This is the right hand side. So if I substitute x prime, so this is x prime, is a x minus f. Okay, so which is so what happens if I don't have this one? If I don't have the, so I made a mistake, yes, obviously. So there shouldn't be, this is not here. Sorry. Plus, this is really a real mistake. Plus f, that's right. Now everything is legal. Fine. Now, part B. Part B. What's A? This one. 3, 1 minus 1, 1. A 3, 1 minus 1, 1. So 3 minus lambda, 1 minus lambda, 1 minus 1. So 3 lambda minus 3, lambda minus 1. This one times this will be plus 1 equals 0, lambda squared minus 4 lambda plus 3 plus 1 will be plus 4. So lambda will be plus 2. Repeated one. Okay. So e to the 2t alpha 0 t plus alpha 1 t times 2. Okay. 2 lambda. How can I obtain the second equation? Yeah, so in the repeated cases, the only option is this guy. Alpha 1 t. So alpha 1 t will be 2 times e to the lambda t. Alpha 0 t will be e to the 2t minus 2 times e to the 2t, which will be e to the 2t minus 4 times e to the 2t. From here, minus 3 times e to the 2t. Oh, okay. So you've got this one. So the answer will be, it's non-homogeneous. X e to the at times c1, c2 plus xp. Where is the xp? So the hardest part is that alpha 1 and alpha 0. So xp is this guy here, xp. So you've got this part, you've got this part, you've got f, you will take integration and you will obtain this part. I will complete this in my handwriting and I will upload it in Canvas. Okay, so the small mistake caused me to not be able to finish this part, XP. The XP was important part. But however, it's just a matter of the calculation slowly. All right, good luck. Have a good break.
So do you think we're in the break?